All right. Good afternoon, class, or I guess good morning, depending on what time it is when you happen to be watching this video. So, today our goal is going to be covering section 1.8 of our Hawks Learning textbook. With that being said, so we are only covering one section today, so it may be a slightly shorter video, but we're going to try to take the time to really talk about some of the examples in this section so that you get a good understanding for them. Because I know in past semesters, many students have had a tougher time with some of these questions from Hawks Learning. So we're going to take that time to make sure you guys get this content for section 1.8. So with that being said, let's see, any housekeeping. So there should have been a homework assignment that I had posted on Canvas for you guys, as well as you should be getting notifications as far as when you have your next certified quiz due. And again, as we discussed with the syllabus, you do have some time to be able to turn in those quizzes. Of course, I mean, if you do them late, there will be a penalty, but it's better to have something than a zero. So keep that in mind. If you happen to miss a day, that's not too big a deal. You're going to be able to make it up without losing too many points if you're just a day late. So don't worry about it too much and be sure you get on that if you are missing any. With that being said, let's go ahead and get into section 1.8. So with 1.6 A and B, we discussed, what is a function, what is a line, what is slope, and really how can we use all this stuff and put it together. So that was more of the mathematical background behind what we're going to be doing next. In this section, we're going to take what we did in the previous chapter section and do some actual business modeling for a real-world application. So with that being said, just as before, we have some vocabulary we want to cover first. So this is section, let's see, can you guys, not quite, let me turn that up a little bit. All right, section 1.8, vocabulary. All right, so the first thing we really want to discuss is, what is mathematical modeling? So anytime you create a mathematical formula, that describes a real-world problem, then that is mathematical modeling. So many of you may have heard the term mathematical modeling before. This is by no means a term to be afraid of. Anytime you've used like a simple linear equation, just a regular old line to try to predict how much money you're going to have over an X number of weeks, or what your rent and your other bills are going to cost you after an X number of months, so on. That's mathematical modeling. So mathematical modeling doesn't have to be the scary thing of using these big complicated equations. Even just using some linear equations to model something in your day-to-day life, that's mathematical modeling. So we've got that covered. Don't be afraid of that. So as we move forward, the main goal of today's section is to get into some business applications. We'll start with some generic terms you might have heard from any economics classes you've taken. And then from there, we'll go into some more specific examples. So for our first thing we want to talk about is, what is demand? Demand. Well, and again, depending on the class, you may encounter different definitions. For the purposes of MAT 1120 calculus, demand is the price you can sell your product at given you want to sell an X number of product. So if we step back for a moment and just kind of think about this, what this is saying is, if you want to sell 100 TVs, then what's the demand for 100 TVs? What price you're going to be able to sell that at? Whereas if you're trying to sell 1,000 TVs, then what would be your demand be? What price could you sell it at? Chances are with most of these demand functions, it has a negative slope. So meaning the more product you're trying to sell, then the lower your price is going to be, which makes sense from what we understand from supply and demand. The more supply you have, then the price you can sell it at should drop. So that's how demand is going to work for the purposes of this class. It's going to be represented as some function. So d of x is equal to, say, 0.05, put a negative there, x, and let's say maybe 100. So what this is saying is, if I have one TV, and only one TV, and that's my x, if x is 1, then the price, based on demand, that I can sell that TV at is going to be 100 minus 0.05. Well, 0.05, that's just like 5 cents. So I can then sell my TV for $99.95, assuming that price is in dollars. If I try to sell 10 TVs, now in this particular case, it looks like increasing my X is going to very quickly decrease my price. But we'll do some analysis later to determine, what is the X you want to use? What is the ideal X that'll allow you to maximize your price or maximize your profit? But we'll talk about that later. But for now, I just wanted to introduce you to what is demand, what a demand function might look like, and how that would play out when you start plugging in different values of X. So, review. X, this is the number of product you're wanting to sell. When we talk about these business problems, X is always going to be the number of your product you're trying to sell. You're trying to sell an X number of TVs, X number of phones, an X number of skateboards, whatever. So this is what demand is, and demand, d of x, is going to equal your price, or P. It's the price you can sell your product at, given the number of X you want to sell. All right, so let's move on from there. That covers demand. All right, we would next like to talk about, if I find my right paper. Yeah, here we go. We next want to talk about revenue. What is revenue? Oops. Well, that marker is dead. Let's try this one. Revenue, let's see. Is that color? No, it's not showing up very well. Yeah, it's not showing up very well. I will go back to black. All right. Revenue. What is revenue? So revenue, you can think of it as the amount of money brought into your business, if I could spell correctly, business, as a result of selling X product. So again, X here is still the number of product we're trying to sell. With that being said, so revenue is often represented as R of X. But more specifically, sometimes you're not given the revenue function. This is something that we'll see examples of in a few minutes. So R of X, it's our revenue, it's the amount of money being brought in. Sometimes you're not given this function, but maybe you're given a way to calculate your demand. Well, this is helpful because revenue and demand have a relationship. What is that relationship? Well, remember, demand you can also think of as your price. So what is revenue? Well, it's the number of items you sold times the price you sold it at. So whatever price you settled on, if you multiply it by X, that tells you how much money you brought into your business. Well, that makes sense. Price times X, that tells you how much money you made. Okay, great. So X times dx, this is going to give you your revenue function. That's going to come in handy when sometimes in these word problems, maybe you're given the demand function, but you don't have your revenue. Well, you can calculate it and then you'll have your revenue. And this revenue function will be important later. So that's revenue. Now, as we move forward, got a few more functions we want to cover before we start talking about some examples. Next, we want to talk about cost. So what is cost? So cost is how much is spent to not only maintain the business, how much is spent to maintain the business, and how much is spent to make X product. I'm running out of space here. So how much is spent to maintain the business, and how much is spent to make X product? Now, oftentimes, cost functions are based on what does it cost monthly, what does it cost weekly, so on and so forth. You'll have different cases depending on the question. But in general, it's how much it's going to cost for some amount of time. And then that cost is based off of A, maybe you have some rent for a building you're using, or you have some flat rate employee salaries that you have to pay monthly regardless of how many X product you make. So then you have your basic expenses that don't depend on X, plus you have some expenses for how much it costs to make 5 TVs, 10 TVs, 20 TVs, however many TVs you make, or however many X product you make. So both of these things are going to come into play when we determine what cost is, and it's important to keep both in mind when we're determining what is the cost function. And again, this will often be based off of what it costs, maybe monthly or weekly, which will be important for some word problems where maybe they'll say, what is the expected profit monthly if this is what it costs monthly to run the business. And so it's important to keep track of these words as you're working through these problems. Sometimes they might switch it up on you. Maybe they'll say, what is your profit monthly if you know it costs some function c of x bi-weekly. So meaning your cost function is set up to tell you what it's going to cost every 2 weeks. Well, to get your cost function to catch up with determining a profit for a monthly number, then you're going to have to multiply your cost function by 2 to determine the cost for 4 weeks or a month. So keep that in mind as you're reading through these problems. That won't happen too often, but it is something they can throw at you trying to catch you off guard. So do be aware of that when you look at these definitions. All right, so we've talked about mathematical modeling, demand, revenue, and cost. We'd still like to talk about a few more terms. Actually, one more term. No, 2 more terms. I was right the first time. 2 more terms before we get into our examples. Now, with that being said, now obviously some of this vocabulary might seem kind of arbitrary, like, okay, obviously I know what cost is, or I know what profit is, demand, so on. You may have very well have seen these terms before and have done these kind of problems before. If that's the case for you, then I apologize in advance if this seems dull or boring to you, but that also means that this will just be easy for you. So you've got that bonus. For those of you that this is new, well, don't worry. We're trying to take this slow to make sure you got these terms in order and it makes sense, so you'll be able to work through the example problems on your own without any issues. So, with that being said, okay, so we've talked about revenue, cost, demand. So we have revenue is equal to, all right, and I am back. So my dog found a way into the room in here when I had the door closed. I had to put him back out of the room. It's quite a traumatic experience for him, but he's gonna make it through. At any rate, so we're talking about business applications. Blah blah blah. Right, R of X. This is revenue. So we discussed earlier that revenue is X times D of X, our demand function. We've also talked about our cost function, and we already talked about the demand function here. So the next thing we want to talk about is what is profit? The actual profit. So profit is the amount of money brought in after expenses. Now this makes sense. Revenue is, okay, this is the money that we got from selling things, but of the money we earned from selling things, some amount of it we're going to lose to costs, expenses, other things. Profit is how much money did you make at the end of the day? Or in other words, profit, P of X, is your revenue minus your cost. So how much money did you get from selling stuff? What did you lose to costs? Whatever you have left over here, that's how much money you actually made at the end of the day. Now, with that being said, remember that the cost function is usually how much it costs per month, per week, bi-weekly, whatever. whatever time frame that cost is being calculated for, that's the same time frame that profit is being calculated for here. So if this is how much it costs to keep your business running monthly, then this is how much profit you get monthly. And there you have it. Additionally, as we know, R of X is also X times demand. You can also write profit as X times demand minus cost. So this is profit. Now the last vocabulary we'd like to cover before we move into some examples is the break-even point. What is the break-even point, you might ask? Well, the break-even point is where revenue equals cost. In other words, the amount of money we gained from selling our X number of items is equal to what it costs us to make that X number of items. The two are equal, so when we subtract, we get a profit of 0, so we've broke even. We've not lost any money in the long run, but we've not actually gained any profit either. So it's called the break-even point when revenue equals cost, when R of X is equal to C of X. And there you have it. So those are the basic terms that we wanted to cover for this section of the textbook. So we have a demand, we have profit, we have cost, revenue, break-even point, mathematical modeling, so on and so forth. All right, we are now ready to move on to some actual examples. What are these problems going to look like? How are we going to solve them? And we'll get into the details. And I do believe that I pushed this around while I was walking. Okay, looks better. Okay, so examples. Examples. So our first example, now these examples are being taken straight from Hawk's Learning. A lot of these are written as word problems, so for the sake of ease, I'm not going to write out the entire word problems, otherwise that's just going to take too long and we're going to be here forever just writing out sentences. So I'm going to read it out to you, but I'm going to make notes on the board as I read out the question. So the question starts, suppose that a company has determined that the cost, so that's the key word there, we're given our cost function, or something like it. They've determined that the cost of producing X items is, so that's equals, $73 per item. So for every X, it costs us $73 to make it, plus a fixed charge of $5,780. So, and I'm going to stop there because there's a period in the word problem. Now, the way they had it worded, they did not give you the equation written like this. They said it in regular old English words, and so from reading these word problems, you're going to have to read it and be able to put it together like this, which isn't too bad to do, but just keep in mind, don't be expecting the equations to be just written out for you. These word problems are going to expect you to put them together for yourself. So there's our cost. Next, we're told that each item can be sold for $243. And that's the end of the word problem. So they can be sold for $243. That's a price. That's a demand. So our demand, it said each item can be sold for $243. Now it didn't say anything about if you have more X that the price will change. If you have less X, the price will be this. If you have so on and so forth. It's saying the price is just always $243. That's just how this particular product works, or maybe that's just a decision that this particular business has made. So the price is just always $243. That's constant. Well, what does that tell us? That means our revenue is going to be X times that, X times 243, or in other words, 243X. So we've got a cost, we've got a revenue, so let's keep going then. So next, the question is asking us for what is the profit function and what is the break-even point. So remember, what is profit? Profit is revenue minus cost. So in this case, I'm just going to write my revenue function, 243x. I'm going to subtract my cost function, so remember to distribute this negative up here. So negative 73x minus 5,780. And so we can clean this up a little bit more. 3 and 3 will cancel. 240 minus 70. That's going to bring us down to, what is that, 170? If I did that correctly? Yeah, 170. And then we still got this flat rate here of 5,780. That's probably like rent for a building or employee salaries or some other costs that are just the same regardless of how much product you make. So here is our profit function. And then the last thing this question asks for is what is our break-even point? Remember, break-even is where our revenue equals our cost. So that's what we're going to do. So I'm going to have 243x equals my cost, 73x plus 5,780. So now all we've got to do is solve for x. So this isn't too bad. We'll subtract 73x over. We're going to get that 170x number is equal to 5,780. We're going to take 5,780 and divide it by 170 to get a final answer of 34. So that's our break-even point, which means if we were to only sell 34 items of whatever this particular product is, then our profit would be 0. We wouldn't make any money, but we wouldn't lose any either. We would have covered our costs, and so we would still be afloat. So x equals 34 is the break-even point for this problem. So there's one example. So let's keep going and look at a few more, because they often will word them in different frames that require you to think about it a little bit differently. In that particular one, they kind of wrote it out in more plain English, so it was easier to see. But as you'll also see in some of these other examples, they can also be sometimes a little cryptic. So, this next one. A manufacturer of TVs can sell, so they're telling us something about what they can sell. They can sell 800 sets of TVs. So that's 800 TVs. 800 TVs at $384. Now, I've put this comma here because this is going to be significant for us as we think about this problem. What this is saying is if X is 800, if I want to sell 800, then I can sell them at a price of 384. In other words, this is talking about our demand function. Because remember, our demand function is saying however many X I want to sell, this is the price I can sell it at. But we're not quite there yet because this is only a single point. We're told if I want to sell 800, then I can sell it at this price. So 1 point is not enough to generate an equation. But let's keep going. That's just the first sentence. If the price is 380, so here we're told if you have a price of 380, if you have a demand of 380, then the manufacturer can sell 1,000 sets, 1,000 TVs. Okay, now we're getting somewhere. We have 2 different points. But still, this isn't quite enough because we don't know if the demand function is linear or polynomial. It could have a squared power or a third power or a fourth power in it. So we don't quite yet know enough based on these 2 points what demand is yet. But we keep reading and we see total cost, blah, 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 blah. Demand. Right. So then they also say in the problem, assume demand is linear. Now that's all they say. They don't give you much else, but this is enough to figure out our demand function now. Now we know our demand function is linear, which in other words means that d of x is equal to mx plus b, equation for the line, right? So now that we know the demand takes this form, we can actually figure out the demand based on the point slope form equation for a line. So just as a refresher, this is y minus y1 is equal to m times x minus x1, where x1 and y1 are some known point on this line, and m is our slope. Well, lucky for us, we already have 2 perfectly good points up here. I'm just going to go ahead and choose this one because, well, it's 1,000 and 380. That's a 0 in the ones place, so that might be a little bit easier calculation-wise. So I'm just going to pick these 2 numbers for my x and y. So when I have 1,000 TVs, I have a price of 380. Okay, so I have my point, but now I need to find my slope. How am I going to find my slope from this? Well, recall that the question says that this is linear. This means we have a constant slope. So between any 2 points on this line, you're going to have the same slope. Well, that then tells us if I calculate the slope between these 2 points, that's going to give me the slope of this line. So let's go ahead and do that. What is slope? Well, like we discussed before in 1.6, slope is rise over run, or in other words, it's the change in y divided by the change in x. So change in y here, I'm going to start with the top minus the bottom. You have to make sure you do it the same way both times or you might accidentally flip some negative. So if you do top minus bottom, you have to do it for the x as well. So top minus bottom, 384 minus 380, that's going to give me a positive 4. And then 800 minus 1,000, that's going to be negative 200. Now we can simplify this a little bit, and this is going to come down to, if we divide by 4 in the numerator and denominator, we're going to have negative 150. So this is our slope. So we got our slope, we have a point. Now we're ready to find our demand function. So we have, and y, I'll go ahead and write y we're going to solve for because y equals, that's what our function is. But more specifically in this case, y is d of x. So I'm going to have d of x minus y1, which I picked 380, is equal to a slope, negative 150, times an x minus 1,000. Now all I'll have to do is solve for d of x. So d of x is going to equal negative 150 times x plus 1,000 divided by 50. That's 100 divided by 5. That's 20. Plus, I got to add the 380 over. So my demand function is negative 150x plus 400. So there's our demand. Okay, this is good so far. So again, in the word problem, it actually still kept listing, like there was still more sentences. But as soon as it said assume demand is linear, and I had these 2 points, I already knew I could calculate for demand. So sometimes it's not a bad idea that as you're working through a word problem, go ahead and write down the information you get from it as you read. And now sometimes you might write down extra information you don't need because depending on the end of the question, maybe it's asking for something where you don't even need demand at all. While that's a possibility, in most cases you are going to need demand, so it's a safe bet. But yeah, so this is how I like to work through word problems. But let's keep going. So we're not done with this problem yet. I'm going to leave the demand function there at the bottom because we might very well need that again later. But we should see what the rest of the question says. All right, assume demand is linear. So let's see, what was next? Blah, blah, blah. Assume demand is linear. Okay. Total cost for producing, so cost, this is our C of x. And in this case, the word problem actually writes out the equation for you, but don't expect that to happen every time. So total cost for producing is 3,600 plus 250x minus 0.01 x squared. So there's our cost. Finally, what is the profit function for this manufacturer of TVs? So now we know what the question is actually asking for. It wants to know what is profit. So let's work backwards. We already know profit is revenue minus cost. Well, we already have our cost function, and we already have our demand function. We don't have our revenue yet, but recall that revenue is just x times our demand. So let's go ahead and do that. So we're going to have for our profit function x times d of x. So I'm going to distribute in x into our demand function here. So I'm going to have negative, and I'm going to move this x into the numerator. So we're going to have a negative x squared divided by 50 plus 400x. That's just x times my demand. Minus the cost. Now remember we have this negative here. Be sure to distribute it when you write out your cost function. So minus cost, so that's minus 3,600 minus 250x plus, because of the double negative, 0.01 x squared. Okay, we're getting somewhere now. So 400 and this negative 250x, I'm going to combine them because they just have x to the first power. That's going to be 400 minus 250, or a positive 150x. Now next we've got this x squared and another x squared. That's 0.01 minus 1/50th. Recall that 1/50th is, you can also think of it as 2%, but 2% is 0.02. So we have a negative 0.02 plus a 0.01, which is going to leave me with a negative 0.01. So this is my term for my x squared when I combine like terms. So negative 0.01 x squared plus my 150x, and then minus 3600. And yeah, there we have it for our final answer for this question. There's our revenue. Or, I'm sorry, profit. And that's the end of that question. So notice for this particular case, because as I was reading the word problem, I went ahead and calculated the demand as I was going along, then I saved myself the trouble of a lot of work later. Because by the time I got to the end of the word problem, I already had my demand, so I could go ahead and plug it into my profit function and get the final answer I actually need for the question. Long story short, it pays off to, make notes for yourself of what information you have as you read through it, and then that's going to save yourself the headache of having to reread the word problem over and over again. So, there we have it. There's our final answer. And let's see. Yeah, we got time for one more example. So in 1.6, we talked about what piecewise functions are, what they look like when we graph them, so on and so forth. But now we'd like to discuss, what does a piecewise function look like when it appears in a real-world business example? And so we're going to see that with this next example here. See, I keep moving this board all over the place. Actually, I should probably lock the foot pedals in place. Okay, here we go. All right, so let's take a look at this last example. And again, this is a word problem, and that's just unfortunately how most of these questions are designed, because in the real world, maybe you don't know what the equation is, but hey, we know that cost goes like this, we know our demand behaves like this. Reinterpret that into an equation, and once you have your equation, you can apply these same techniques we're using right now. So, let's move on to this example. For a long-distance call, the telephone company, so this is for a particular company, charges 65 cents. So assuming that the money is in dollars, I'm going to write 65 cents as 0.65. So they charge is a cost, so this has something to do with our cost function. They charge 65 cents for the first 3 minutes or less. So let me stop there for a moment. They're charging for what? They're charging for number of minutes. So the product that they're selling in this case is minutes, and X number of minutes. So let me look over that again. It said 65 cents, that's a flat rate, for the first 3 minutes or less. So in other words, if the number of minutes that I'm wanting to buy is less than or equal to 3 minutes, now obviously it'd have to be bigger than 0 because You can't buy negative minutes. That doesn't make sense. So if I'm buying 3 minutes or less of minutes, then it's going to cost me 65 cents. Okay. So let's keep reading then. So the company charges 65 cents for the first 3 minutes or less. Got it? Plus 15 cents for each additional minute. So if I go over 3 minutes, then I have my original flat rate plus 15 cents per minute over 3. So plus 0.15 per minute when x is greater than 3. Write a cost function for a call x minutes long. So in the case of this question, they only ask you for the cost function, so then this is our final answer. But the whole point of this question is, by the way, don't forget about piecewise functions because they can still pop up in these types of questions. So watch out for that in the wording when you read these word problems, and understand that when they talk about different costs or different prices or different profits or different revenues based on when X is bounded by different minutes, like if I'm selling less than 10 TVs, maybe my cost is low reduced. And then in that case, that would be a piecewise function. So pay attention to the wording. This will be important, and you may not see it a lot, but it is something that Hawks Learning might try to trip you up with. So there you have it. So that was that covers the basics of section 1.8. We've covered our vocabulary. We have worked through most of the examples that you're going to see in the practice section. With that being said, don't be afraid to work through Hawks Learning, and take the practice because you're not going to lose any points for that. So if you're feeling shaky on it, you can spend as much time on the practice as you'd like with no penalty to yourself. Make sure you're ready before you do the certify. That way you can actually pass the certify when you take it and get full credit for that. Those will count as a quiz grade. So with that being said, that was all I wanted to cover for section 1.8. Of course, we'll have an opportunity for Q&A later. So by all means, don't be afraid to email me, or you can message me on Canvas directly if you'd prefer. With any questions, concerns you may have, any problems you're encountering with Hawks Learning and such, and we'll do what we can to make sure you have what you need to make it through this class. With that being said, that's everything I wanted to cover today. So we're going to go ahead and sign off here. So I hope everyone has a wonderful day.